requirement for ground fault circuit interrupter protection within 4 feet of any water source is not found in the 2002 National Electrical Code or the 2004 National Fire Protection Association 70E. It is possible that this requirement is based on an older version of the code, but it is not current. The current National Electrical Code requires ground fault circuit interrupter protection for receptacles located in the following areas: firstly, bathrooms; secondly, garages; thirdly, outdoor locations; fourthly, crawl spaces; fifthly, unfinished basements; sixthly, kitchens; seventhly, laundry areas; eighthly, boathouses; and finally, marinas. The National Electrical Code does not require ground fault circuit interrupter protection for all receptacles that are within 4 feet of a water source. However, it is good practice to provide ground fault circuit interrupter protection for any receptacle that is likely to be exposed to water, such as those located near sinks, showers, or bathtubs. Portable ground fault circuit interrupters are not a substitute for permanently installed ground fault circuit interrupters. Portable ground fault circuit interrupters can be easily damaged or disconnected, which can leave workers unprotected. Permanently installed ground fault circuit interrupters are more reliable and provide a higher level of protection. I recommend that you implement a ground fault circuit interrupter testing program in your facility to ensure that all ground fault circuit interrupters are functioning properly. This will help to protect your workers from electrical shock and electrocution. Ground fault circuit interrupters, or GFCIs, are critical safety devices designed to protect individuals from electrical shock. Understanding their function and proper implementation is essential in any facility, especially in industrial manufacturing environments. The primary function of a GFCI is to detect ground faults, which occur when electrical current deviates from its intended path and flows through an unintended conductor, such as a person. This can happen when insulation on a wire fails, or when equipment malfunctions. The GFCI continuously monitors the current flowing to and from an electrical device or appliance. It measures the difference in current between the hot or energized conductor and the neutral conductor. Under normal conditions, these currents should be equal. If a difference of 5 mA or more is detected, the GFCI quickly trips, interrupting the circuit and cutting off the flow of electricity. This happens within a fraction of a second, typically around 20 to 30 milliseconds, minimizing the duration of the shock and significantly reducing the risk of serious injury or death. GFCIs are designed to protect people from the hazards of electrical shock, particularly in areas where there is a high risk of contact with water or other conductive materials. The National Electrical Code, or NEC, outlines specific requirements for GFCI protection in various locations. It's important to stay updated with the latest edition of the NEC, as requirements can change. The NEC mandates GFCI protection in several key areas. As previously listed, these commonly include bathrooms, garages, outdoor locations, crawl spaces, unfinished basements, kitchens, laundry areas, boathouses, and marinas. In bathrooms, all 125 volts, 15 amps and 20 amps receptacles must have GFCI protection. This is due to the presence of water and the increased risk of electrical shock. In garages, all 125 volts, 15 amps and 20 amps receptacles must have GFCI protection as well. This includes receptacles used for power tools, appliances, and other equipment. Outdoor locations, where electrical equipment may be exposed to rain, snow, or moisture, also necessitate GFCI protection for 125 volts, 15 amps and 20 amps receptacles. Crawl spaces and unfinished basements are prone to dampness and moisture, making GFCI protection essential for all 125 volts, 15 amps and 20 amps receptacles. Kitchens require GFCI protection for receptacles serving countertop areas, as these are frequently exposed to water and food preparation activities. Laundry areas, due to the presence of washing machines and dryers, demand GFCI protection for all 125 volts, 15 amps and 20 amps receptacles. Boathouses and marinas, given their proximity to water, require GFCI protection for all receptacles. It's important to note that the NEC specifies the types of receptacles that require GFCI protection. Generally, these are 125 volts, 15 amps and 20 amps receptacles, which are the standard outlets found in most homes and businesses. The NEC provides detailed guidelines and diagrams to help ensure proper installation of GFCIs. Understanding these requirements is crucial for maintaining a safe electrical environment. While the NEC provides a baseline for GFCI protection, it's often prudent to go beyond these minimum requirements. Providing GFCI protection in areas where there is a potential for exposure to water or moisture, even if not explicitly required by the NEC, demonstrates a commitment to safety. For example, receptacles located near sinks, showers, or bathtubs should ideally have GFCI protection, even if they are not located in a bathroom. In industrial settings, additional areas to consider for GFCI protection include those with machinery that uses water or other liquids, as well as areas that are frequently cleaned with water. The two primary types of GFCIs are receptacle-type GFCIs and circuit breaker-type GFCIs. Receptacle-type GFCIs are installed in place of standard electrical outlets and provide protection only for devices plugged into that specific outlet. These are commonly used in residential and commercial settings. Circuit breaker-type GFCIs are installed in the electrical panel and provide protection for an entire circuit. These are often used for circuits that serve multiple outlets or appliances. When selecting GFCIs, it's important to choose models that are listed by a reputable testing laboratory such as Underwriters Laboratories or all. This ensures that the GFCI meets industry standards for safety and performance. The selection between portable and permanently installed GFCIs is another important consideration. Portable GFCIs are convenient for temporary use and can be easily moved from one location to another. However, they are not a substitute for permanently installed GFCIs. Portable GFCIs can be easily damaged, disconnected, or misused, which can compromise their effectiveness. Permanently installed GFCIs offer a higher level of protection because they are always in place and are less likely to be tampered with. In industrial facilities, permanently installed GFCIs are generally preferred for their reliability and consistent protection. Implementing a comprehensive GFCI testing program is crucial for ensuring that these devices are functioning properly. GFCI should be tested regularly to verify that they trip when a ground fault is detected. The NEC recommends testing GFCIs at least once a month. The testing process involves using a GFCI tester, which simulates a ground fault. The tester is plugged into the GFCI protected receptacle, and the test button is pressed. If the GFCI is working correctly, it will trip, interrupting the circuit. If the GFCI does not trip, it should be replaced immediately. A GFCI testing program should include documentation of all tests performed, including the date of the test, the location of the GFCI, and the results of the test. This documentation can be used to track the performance of GFCIs over time and to identify any potential problems. In addition to regular testing, GFCIs should also be inspected periodically for any signs of damage or wear. Damaged GFCIs should be replaced immediately. Training employees in the proper use and testing of GFCIs is an essential component of a comprehensive electrical safety program. Employees should be trained to recognize the signs of a ground fault and to understand the importance of GFCI protection. They should also be trained on how to test GFCIs using a GFCI tester. Regular training sessions can help reinforce these concepts and ensure that employees are aware of the latest safety procedures. Ground fault circuit interrupters are life-saving devices that protect individuals from electrical shock. Understanding the requirements for GFCI protection, selecting the appropriate type of GFCI, and implementing a comprehensive testing program are all essential for maintaining a safe electrical environment in any facility. By prioritizing GFCI protection, you can significantly reduce the risk of electrical injuries and fatalities. Furthermore, it's important to keep up to date with any applicable local regulations in Salt Lake City, Utah regarding electrical safety and GFCI requirements, and to consult with qualified electrical professionals for advice tailored to your specific facility and needs. Remember to always prioritize safety when working with electricity and to follow all applicable codes and regulations.